In this video, we're going to go through how to use Desmos to do what's called a linear regression. Sometimes it's called a line of best fit, but we're going to use the computer to generate a function that will approximate a data set. Now, in Desmos, you can plot points by clicking in the window and simply plotting the point, okay? And I plotted 2, 3, and you can look over at the screen over where 2, 3 is, and you can see, there's the point. And you can also label the points. So you could go ahead and say point 1, and my students have done that, and it can be useful, and you can do more than 1 point. Okay, but Desmos is going to recognize that as being these isolated points. And if we want Desmos to do a regression for us, the points need to be clumped together as like a set. Okay, and so to do that, we need to put the points in a table. If you look at where my mouse is hovering, hopefully it's showing up. It's on the upper left side of the screen. There's a plus sign, and the little hand is hovering over that, and it says Add Item. So I'm going to go ahead and click on that. And you can see that there's many things we could add, but we are going to add a table. And that is how we put the table in. So I'm going to add the table. And notice that it says X1, Y1. That is Desmos's way of just saying these are the X's and the Y's for table 1. Now, just for funsies, okay, if I do the same thing in the next line, it automatically says X2, Y2, and that just means it is the second table. If I do it a third time, okay, it will tell me X3, Y3, and for some reason it appeared at the top. I think I moved my mouse. But that subscript, all that subscript means is it's distinguishing which table we're dealing with. So I will typically keep it on 1, but I have had students accidentally open up more than 1 table in a lesson. And then when we do the regression, they use a 1, and really they should be using a 2 or 3. So I'm going to enter some points here. So bear with me. You just kind of have to use your buttons and navigate around the table. And this is where practice can become so helpful. You can know how to do something, but you need practice at getting quick and efficient at it, like learning the different shortcuts and so forth. So don't skimp on the practice. So what we did there is we now inputted all of the data from that table. Now, there's a couple of things you can do with the viewing window. If you look at what I can see, I have a lot of space down here that I'm not using. Over here on the left is about center left of your screen. There's a little magnifying glass with a plus sign in there. That usually means zoom, and you'll see that it's highlighting as zoom fit. If I click that, it will change my viewing window to put my points in the center. Okay, so I'll go ahead and click it, and you'll notice what it did. It got rid of some of that extra space down at the bottom and gave us a more comfortable margin at the top. And that can be really useful because sometimes when you're doing application problems, you'll have huge numbers like tens of thousands, and they won't be on that default window. And so you can click zoom fit. Now, if you decide you don't want it, over here on the right-hand side, you'll see a little house, and that little house says default viewport. Okay, so if I click that, it will give me get me back to that original window really fast, but we'll keep it on the zoom fit. Now, looking at these points, they appear to be linear. You might think that there's a little bit of a curve there, and you might be right. Okay, that is kind of a discussion for another time. Do I actually think that these points look like a line? Yeah, but they do today. Okay, they look like a line. So in my next line down, here's how we get Desmos to give us the equation of that line. We're going to use y equals mx plus b. Okay, will be the form of the line that we're going to use. But if I just type in y equals mx plus b, where's my, there we go. You'll notice that it first of all, does not put any line on there. It doesn't tell me anything. And it gives me this option to add sliders, and you're getting the warning thing there. Too many variables. Okay. Too many variables there. So what we do is we need to tell Desmos, take the points we already have and make like the line from those. So instead of Y, we're going to type Y1. And you can do that just by hitting the 1 key. Okay, if you type Y and then the number 1, it will automatically make it a subscript. You don't have to hit anything to make it be a subscript. Instead of an equal sign, we're going to use a tilde. Okay, now that is usually located up by the 1. Mine is to the left of the 1. And that is what we call syntax. It's not the equal sign, but it's going to tell the computer program what you want it to do. And then we'll have M and then X1. Okay. And again, we need to establish, yes, use the data from table 1. If you had table 2, if you had X2, Y2, you would just type a 2 there instead. And then plus B. And now it is giving me the equation of a line. It is telling me what the M and the B values are. So the slope of that line is 0.607, blah, blah, blah. And the y-intercept is about 1.8. Okay, you can go over there and click on the y-intercept and it'll put the point up there for you. And then it gives you some statistics. So now this is not a stats video, but essentially those numbers tell you how good of a fit this is. Like how likely is this that this relationship is a line. And I'll look at one other example before I close out the video so you can see like some contrast there, but kind of remember what those numbers are, like 0.94, 0.97. And now you have your mathematical model and you can do a lot more with Desmos. So again, if you thought the lines were curved, once you study what curvy things look like, you can do a regression for that and it will pretty much do the same thing. It'll give you the key pieces of information. Now let's look at some other data. And this is where this might go a little astray. I am going to just type in some stuff. Okay, so there is no rhyme or reason to what I am doing here. We're going to do another -1, 7, and a 4, 8, and we'll do a -6, -1, and where do we want to go from here? Let's do 6, 0. Okay. Now, if you look at those points clearly do not seem to be on a line. Okay. And that was on purpose. I'm like, I'm looking at the points and, because we don't want to think like all the points, always look like they're a line. Like this does not look like a line. I'm not sure what it looks like, but not a line. Now, when I go to have Desmos do the regression, okay, Desmos is not going to judge you. Okay. It is not going to tell you, hey, that should not be a line. It's going to come up with the line, but notice these numbers here. Before they were really close to 1, they were like 0.9. So, and change, that means that like the closer it is to 1, that like 0.9 means this is a pretty good relationship. Like this data looks like it's linear. Notice these numbers like 0.04, 0.2, much, much, much lower. And what that means is this data this is not a line. That's what that means. And so if you're taking a more advanced math class, you might pay more attention to those stats. My students in my algebra classes, we don't typically pay attention to that. We're just looking at doing the regression, but you can pay attention to that as well. And there's some other stuff you can do there as well. I just click the button for what's called the residuals. And I know in pre-calculus classes, you would talk a little bit about the residuals, but there you go. All right, so you should have the skill set now to do a linear regression in Desmos, and make sure that you like the video, subscribe to the channel if you would like more help. And if this was really helpful or you'd like to see more Desmos videos, please drop a comment. Let me know what kinds of videos you would like to see that you think would be helpful demonstration videos.